Welcome to Csis 237. This is a series of videos for lecture 13 that is looking at inheritance in C++. Now we're going to try to go through this really quickly, and we're going to compare as much as we can with Java. So I'm going to assume that you know inheritance and how inheritance is used in Java so that you can quickly get up to speed using inheritance in C++. Okay, so some of the basics, you can have what are called derived classes, and in Java we use the word subclasses or descendant classes. It's the same idea, and the opposite, or the derived classes, are derived from, in this book we refer to base classes. That's the superclass. So there's a little bit different notation, but I think once you get the hang of it, won't be a problem. So we look at constructors, how constructors of when you set up an object of a subclass or derived class, you end up calling the constructor of the superclass or the base class. We look at protected. Works the same way in Java. There is no default visibility in C++. There is only private, protected, or public. We'll see how we can redefine member functions. So now, because C++ has two ways of inheriting member functions, that is either virtual or not virtual, this is slightly different from in Java. So let me back up and say that we will look at virtual functions or virtual method members in the next chapter. But a quick description of virtual. Let's just look at it by comparing with Java. In Java, all our methods are virtual. So keep that in mind. Even if you don't understand what virtual are, keep that in mind that in Java, all methods are virtual. In C++, we have the option of making it virtual or not virtual. So I haven't even really explained what virtual is, but you want to keep that one fact in mind. In Java, everything is virtual. And I think as we go along, we will look at virtual. Actually, that's in the next chapter. But that'll become important when we look at overriding functions. Okay, so when you use virtual functions, you can override. When you don't have virtual functions, what you do is redefine member functions. So even if you inherit a function from a superclass or a base class, you can redefine it, but then you still have access to the function that you redefine, that is the function in the superclass. So that's different from Java. So there are some things that are going to be different. I'm going to try to point these out. Another thing that's different is there are some things that you do not inherit from your parent or your base class or your superclass, however you call it. So some things you do not inherit in C++. Okay, and then we'll talk about programming with inheritance, look at assignment operators and copy constructors. These are tremendously important. Once you get them right, everything just sort of works, but you want to understand how this assignment operator works hand in hand with the copy constructor. We'll also want to look at destructors and a quick, I just want to mention very quickly that when you use destructors, the key thing is always make destructors virtual. And actually, if you've used Eclipse to create a new class, you will see that Eclipse automatically creates destructors, and they're always virtual. Now, there's nothing in the language that's in the C++ language that says that destructors have to be virtual. It's just a really good idea to make all your methods, actually, or at least your destructors, make your destructors virtual. So when Eclipse sets it up as virtual, leave it alone. Probably don't change it. And we'll talk about it. The book actually says that it's not such a great idea to make things virtual. I don't think that is the best advice. I sort of disagree with that advice. And the book makes that suggestion based on efficiency. And I don't think we have to worry that much about efficiency anymore. Maybe a few years ago we did, but not anymore. Another big difference between Java and C++ is multiple inheritance. In C++, you can have one class extend or inherit from two classes. Java, you cannot do that. Java, you can only inherit from one class, but you do have this limited form of multiple inheritance in Java. That is, you can implement any number of interfaces. But that's very limited. That's very sort of limited inheritance. In C++, it gives you, full multiple inheritance. You can inherit from 10 classes if you want. And now there are plenty of reasons why you should not use multiple inheritance. A lot of people think this is actually something that should have never happened in C++, but the designers of C++ let that pass, and we've been dealing with problems ever since. So a rule of thumb would be don't use multiple inheritance. Use just single inheritance. It'll make your life simple. There's very seldom a case where you need multiple inheritance, and whenever you do, you can try to remember the thing that you might have seen in Java is that composition is always better than inheritance. Almost always. 99% of the time, prefer composition over inheritance. If you think of it that way, there's no need to have multiple inheritance. Alright, I'll leave it at that. Okay, let's do a quick introduction to inheritance. Most of you have seen all this. This is a very powerful aspect of object-oriented programming. Excuse me. And it provides an abstraction dimension called inheritance. That is, it's a way to reuse code. You set up a base class that has a lot of the features that you want, that's common to a lot of classes, and then you use inheritance to inherit all those things and then add just what you need. So a general form of a class is defined, and then specialized versions then inherit all of those things, plus the specialized versions add to it or modify its functionality for appropriate use. So the example that's used in this book is that of an employee class, and you get that's the base class or the parent class, and then you use an hourly employee class that inherits from employee class and adds additional features to that class. So all of this is going to be, not all, but a lot of this is going to be very familiar, and I'll just try to point out the differences with Java. A new class inherits from another class. The base class is the more general class from which others derive, from which you derive other classes, and so you have a base class, which is the superclass. Derived class is the subclass. So this is also referred to as the parent class or ancestor class. The derived classes are also referred to as superclass or descendant classes or the child class. Those are all terms that you will run across. Okay, so this is the new class. It's based on the base class, and if you use inheritance, it automatically gets all of this stuff from the base class for free, like member variables, member functions. And then you can add additional member functions and variables in the derived class. So the example that the book uses in chapter 14 is the employee class. And let's say we have two kinds of employees: salaried employees, that is, they're paid fixed amount by per month, let's say, or per year, and then the hourly employees. So these are two kinds of employees. Each is, you can think of it as a subset of employees. So there might be yet another or a third kind of employee that's paid a fixed wage each month or week. Okay, so derived classes, you do not need a type of generic employee. That is, you may never use an instance of this class generic employee because there's no such thing. So since no actual person in a company, let's say you're using this in a company, is just a plain employee, that doesn't happen, but it's still useful to have a class in our code. Even if you never have to instantiate this class. It's generally useful to organize your code to have such a class. And we've run across this before in Java. We set up abstract classes in Java. Abstract classes are classes that we never actually instantiate, but they're used, for in a lot of cases where you have to use inheritance to make specialized or more concrete classes. And we will sort of run into the same thing here, only there is no keyword abstract in C++. Okay, so the general concept of an employee is helpful. It's helpful in our code. All employees will have a name, a social security number, and maybe an ID number for the company that they're working in. So these things are all basic and they are shared among all employees. So let me just stop here and say, typically we do not design these classes from the top down. We actually do start with actual classes for real world objects, and then pretty soon what we see is that some of these classes have many things in common, and we can abstract out the common stuff into a common class, and in this case that would be the employee class. And then we use inheritance to create the specific things that specific classes that we really do use in the real world, sort of. So this is very common. It happens a lot. You start out with classes, many different classes, and you realize a lot of these classes share certain things. You abstract them out into a parent or a base class, and then you use inheritance to just add the things that you need. Very useful idea, very useful part of object-oriented programming. Okay, so the general class or the base class can contain all of the things that are common to all employees, and then you add other things to the subclasses. Many members of this employee class apply to all types of employees. So things like access or get functions, or mutate or set functions. Most of the data members, like name, social security number, maybe date of birth, I don't know, and then the pay rate or something like that, that might be common. So even if we never have objects of this class, we still, a lot of times, in a lot of situations, we will end up with this situation where it's nice to have a class that we derive from. Okay, so let me stop here and then we'll continue with this employee class example in the next video.